over to you, Kit.
Thank you, Lily. And hello, everyone, and welcome to the webinar. As Lily said, this is a webinar on post-processing with the RT-Range Suite. And then the aim of the webinar is to allow you all to be able to use the RT-Range software to access all of the measurements that using our devices allows you to measure, even after you have performed the testing. So I want to quickly, before we go into the software, give everyone an overview of the different file types which are used with both the RT devices and the RT-Range devices, and what is contained in each of the different files. I'll also give you an example, show you some of these files as well in action. So to start with, we'll just go over the RT files. So on an RT device, there will be certain files which are stored on the internal memory of the RT by default, and these are RD files. RD stands for raw data, and these files contain the raw acceleration and angular rate data from the IMU, and also all of the measurements from the GNSS receivers. Also stored on the device is the mobile.cfg files, so all of the config files that you created using the nav-config software and then sort of committed to the device. So I'll just show you how to access these files. So you can use an FTP client like FileZilla, or you can use File Explorer. You just need to know the IP address of the unit. By default, this will be 195.0.0. And then the last two numbers will be the final two numbers of the serial number of the unit. Okay. So here you can see all that's contained on the unit is mostly a series of .rd files. So these are raw data, and the file names are the reverse date followed by the time. So for example, you can see here they're all from 2020. Then the 04 in the middle signifies April, and then this will be like the 15th of April at 8:35, 22 seconds. So that's the time and date which this RT was turned on, and by default it starts to store all of the data in this RD file. Then after that we have a lot of mobile files, and these are all of the configuration files which are pushed onto the unit when you've entered all the measurements in nav-config and committed them. Okay, so those are the files which are stored on an RT. Now there's also another file type associated with an RT, which is the ncomp file. So when you have turned on an RT, it will start to stream or broadcast its measurements in an ncom stream. So ncom is a OxTS sort of standard of data, so it's not a commonly used file format, and this contains the process navigational information. So the purpose of an RT, well, not the purpose, the RT is a combined GNSS and INS device. So it takes measurements from satellites and from the IMU and combines these together using a Kalman filter. And it's only in the NCOM stream that the measurements come from the combination of the sensors, whereas in the RD file there, it contains the raw data from the sensors separately. And the NCOM, these processed navigational data is the measurements with the higher accuracy which you will want. So if I show you in nav display, so this is the software contained within nav suite, which we use for monitoring the real-time output of the device. This is where you can view the NCOM file. So you're sort of viewing the NCOM stream from the RT. But as you can see, when we looked on the memory of the device, there aren't any NCOM files stored here. So if you want to save an NCOM file, you have to use a tool like the test and save functionality of nav display. So if you go to utilities, test and save, there's this utility here where you can select a stream. So from an RT, you can see here that the stream is an NCOM stream. So you tick this box here, and then you can just click start, and then that will just start recording the NCOM output of the RT. I should probably stop that. I didn't start it. Okay. So that's just the RT side of it. Next, we'll go on to the RT range. So unlike the RT, there isn't any raw measurements stored on the RT range device, and that's because the RT range hardware doesn't actually contain any of its own internal sensors. It is just a processing device. It just takes measurements from the Hunter RT and any target RTs you have on the system, and then uses those measurements to calculate the range measurements. So if I do the same thing I did before, but with an RT range unit, you'll see here there's much fewer files and only really the configuration files. So this is the file that you create when you go through the configure RT range application and then commit a configuration onto a unit. That configuration will be stored here in the CFG file. So other files, so in that example, there was a configuration which was a CFG. That's because I was looking at the files on a V2 RT Range S device. We do have a new generation of products, the RT-3000 V3, which is a combination of RT and RT Range. So the RT Range functionality is now on board the RT in the RT-3000 V3. And the configuration file on a V3 is actually a .rng file, and that's to avoid it clashing with the RT configuration file. Other files you would have seen on the RT range device just now are the map file. So if you are looking for lane measurements, you will need to have pre-surveyed those lanes and created a map file and put that on the unit as well. And also maybe a feature point file as well if you have pre-surveyed some feature point targets that you want to measure to. And then finally, In red here, we have the RCOM, which is similar to the NCOM of the RT. The RCOM isn't actually stored anywhere by default. It is broadcast from the range device and contains all of the processed range data. So all of the measurements, which would be your distance between targets, your relative velocity measurements, your relative orientation measurements, your time to collision, this is all stored in the RCOM stream. And to capture this, you need to be logging it in real time, which you can do in the same utility in nav display, the test and save, or there's also the start logging function in the RT-Range real-time display application, which you can see opens exactly the same module. So when you're selecting your streams, you just want to choose the RCOM stream here, which will be associated to the IP address of your RT-Range device. And by selecting that and choosing your working directory and file name, you can just click start and it will start to capture all of those range measurements. So just a quick recap. So what is contained in the raw data? So the raw data is the RD file, which is stored on the RT-3000, for example. And contained in that RD file is time, measurements from the GNSS, as well as a position solution and velocity solution, which are GNSS only. There's also the raw IMU measurements, which would be the accelerations in X, Y, and Z, as well as the angular rates in X, Y, and Z. Also contained is the initial configuration, which was saved on that unit at the time that those measurements were being taken. But then in the red is the stuff which is not contained in the raw data. So orientation, so when in the raw data, all of the measurements are in the X, Y, Z orientation. So these are the three axes which the sensors are mounted on physically in the IMU. So you don't get any measurements of orientation like your heading, pitch and roll, or measurements in the vehicle frame. So any forward or lateral measurements. You also don't get any velocity measurements or position measurements from the IMU because these need to be processed from the acceleration and angular rates measurements. You won't get any RT range measurements sort of stored by default in the raw data. So these are all calculated by the real-time processor of the RT range and output in the RCOM stream. And you won't have any measurements which are combinations of the GNSS or IMU output. And the way our system achieves its high level of accuracy is by taking the output of all the sensors and combining them in the Kalman filter to produce a single position, velocity, or those kind of measurements, are more accurate measurements. And those are really what you want. So how to access these measurements, the sort of process measurements that I was just talking about. So there are two ways. One way I've kind of showed you briefly is using the data logging module in RT-Range. So once you have your test set up and you're about to perform your test, you can simply press the Start Now button and it will start logging all of these data for all of these measurements, all of the RT range, and processed RT measurements in real time. And then once you finish the test, you can just hit stop, and it will create an RCOM file for you and an NCOM file for you, which will contain all the measurements that you need. However, that does need to be done when you're in the vehicle with the test, and sometimes you might want these measurements from a test which has been done previously, and you can't just simply press start logging. So the aim of this webinar is to show you that you can actually generate all of these measurements in post-process as well. So the first thing you'll probably need to do is use the NavSolve application in NavSuite. I won't go into too much detail into NavSolve because we do have a whole webinar on post-processing using NavSuite. So I'm just going to go over the main functionality here. So in NavSolve, you have two options. You can either take a live logged NCOM file that you've logged during a test, and you can select the specific measurements you're interested in from that NCOM file and convert them into a CSV file format. The other option, so if you haven't logged any files during your test, as I showed you earlier, the RT file, the RT device stores raw data on it, and all of this raw data is dated, and the internal memory of the device is 2 GB, so it stores a lot of raw data on there. So if you are interested in data from a previous test, all you need to do is FTP into the device and find the RD file from that date and time, and then you can use NavSolve to process the data. So NavSolve contains the same processing engine that the RTs have, so it will sort of simulate that real-time processing and create an NCOM file for you, just as if you had logged it from the RT's output. And then you can use that NCOM file again to select the specific measurements that you're interested in and create a CSV file containing those measurements. So this is a necessary step because when you come to generating your range measurements, you'll need the NCOM file generated for a Hunter and any target vehicles you have. So yeah, now I'm just going to move on to what you can do with the RT-Range post-processing tool. So it contains the same functionality that NavSuite has, only it's aimed at RCOM files. So this time you can take a live logged RCOM file if you remember to start and stop logging during your test, and simply select the measurements you wish to look at and convert those into a CSV file format. Or if you weren't logging the RStream of the RT range, you can get the NCOM files from any Hunter, from the Hunter in any of your target vehicles. And you can generate an RT range configuration, or you can take the file from your RT range device. And if you want lane measurements, you'll also need a map file of those lanes as well. And then the RT range post-processing wizard takes all of the measurements from the NCOM files and looks at the RT range configuration and processes them the same way that an RT range system would in real time to generate an RCOM file. And then this RCOM file would contain all of the range measurements, so distance measurements, relative velocity measurements, time to collision measurements from that test. And then you can select the measurements you're interested in to convert to CSV. So if you were looking to post-process data from a test and you're interested in specifically in vehicle to lane measurements, you would need to generate an RCOM file from an NCOM file. The NCOM file would need to be from the Hunter RT. You would need a configuration file from the RT-Range device, and you would also need a map file of that lane. And I'm going to just go through an example of this. So here, this is what it looks like when you open an NCOM file. You can see this is the NavGraph window. So NavGraph is an application contained in NavSuite. In the top graph, it's just looking at the speed of the RT measurements. In the bottom, you can see in the bottom left here, you can see a map. So you can see it's just doing a slalom maneuver. And this is an example of the map file used. So just 2 lines surveyed to create a lane with a start line on the far right. And then this is what it looks like when you sort of export the map and the position trace of the RT into Google Earth. So you can see the slalom is just going to be performed between the 2 lane lines. So now I'm just going to open the RT-Range post-processing wizard and walk you through how to generate lane measurements. So the first thing you need to do is choose the NCOM file from the Hunter vehicle. As I said before, like if you don't have this NCOM file, you can create it using the RD file, so the raw data which would have been stored on the unit and would still be there as long as it's not been deleted. And just use navsolve to convert that into an NCOM file. So once you've chosen the Hunter NCOM, you need to create or upload a range configuration file. So I'll just show you that you can create one from scratch if you don't have the same file. So you just choose the default settings option. And you'll also need to upload a map file. So this will be the map of the lane from the slalom maneuver. So there we go. Cool. So because we haven't selected an NCOM file, because we haven't selected a configuration file, it's giving us the option to set up some targets, and it will, we don't have any targets for this example, so I can skip through this. It's then asking us if we want to set up polygons or multi-sensor points, but again, not necessary for this example. And the only thing that we would be interested in, because we're only looking at lane measurements in this example, would be this section here. So if the vehicle has a standard setup, you might be able to, you might know the measurements from the RT to other parts in the car. So typically, when you're looking for lane measurements, you're looking at A, which will be in the center of the vehicle, and then B and C, which would be the far left and far right side of the vehicle. And these are normally placed on the part of the vehicle which crosses the lane first. So maybe the front tires. So if I knew the measurements from the INS to the front tires, I could add those in here. And then it gives you options to enable local coordinates if you want measurements in X and Y, for example. So once you've gone past that page, it will generate the RCOM file for you. And then when you're on the select fields section of the software, this is actually when you're creating a CSV file from that RCOM file. This is when you're choosing which measurements you want to contain in that CSV file format. So for example, I'll just do distance along line 1 and then some lateral distance measurements. Okay, and now you can choose to skip time at the beginning of the file. So if you know that file contained a 15-minute warm-up that you don't want to output measurements of into your CSV file, you can simply type in a number of seconds here and it will skip that. And you can also choose the measurement units that you want to use. And then you can simply tick the export tick box here to ensure that this file is saved into CSV. And export. And then we can open that CSV file here. And you can see it has measurements, distance along line 1 negative here because it's behind the line. But that's essentially how the post-processing works. And next, we're just going to go through a very similar example, but this time using target data as well. So instead of just generating lane data, we're going to generate some range to target data as well. So to do this, you'll need, just like before, you'll need an MCOM file from your hunter. But you'll also need an NCOM file from any target RTs that were set up during your test and a configuration file from the RT range. Again, if you don't have that RT range configuration file, you can generate it in the software. Yeah. So this is how the data looks when you look at the individual NCOM files. So you can just see there driving in a convoy. And then this is the position trace of those NCOM files. So they're just driving from the same start point, one behind the other, to the same endpoint. And now I'll take you through the post-processing wizard again. Okay, so we're going to choose the hunter NCOM file first. This time we're going to read from a file. So I have a .rng file, which is the configuration of a v3 set up already. And now if I go to the next page, I'm not going to use the map file. We're just looking at the target data. But these should be set up. So the configuration file I loaded up had the RT range set up with 2 mobile targets, which is why this is populated already. For each mobile target, you'll need to associate an NCOM file. So target 1 NCOM and target 2. And you can see it's read in the polygons and multi-sensor points that were set up during that test because we read from the file. And this time we're not going to worry about the lane measurements. And we're going to need local coordinate setup because polygons are 2D and require the local coordinates. So when I click next now, because the next section is the select field section, I want to click next. This will be generating that RCOM file from the NCOMs and the configuration. And then the last step is to choose the measurements which you wish to add into the CSV file. So maybe the lateral, forward, and horizontal range of each target, for example. I'll get rid of the lane measurements. Cool. And then we can open that CSV file. It should contain some measurements. So it's usual for the first few rows to be empty. But here you can see the measurements created as expected. Yeah, so those are the two examples. Thank you for listening. I'm sure you have questions about some of that. So we have 15 minutes now to go through any questions that you have submitted.
Hi, Kit. Thank you for that. We'll just go through the questions that have been submitted, but if anyone does have any more questions to submit, you can do that now just through the question box. Okay, so first question. Is an RD file time always in GPS time?
Yeah, so the GPS is always used for the time measurements.
Okay, thank you. Does the range unit also store the static points like lane boundaries, or do they need to be stored on the RTs separately?
Sorry, could you repeat the question, Lily?
Oh, sorry. Does the range unit also store the static points like lane boundaries, or do they need to be stored on each RT?
Okay, so yeah, if you set up some static points like lane boundaries, the lane boundaries will all be saved in the map file, which is stored on the RT-Range device. And similarly, if you have fixed point targets, those will be stored on the RT-Range as well. There's no need to store any lane boundaries on any of the RTs being used in the test, just the RT-Range.
Okay, thank you, Kit. Are there any capabilities of RT-Range post-processing available in API to call for from Python or similar?
We don't have any command line RT-Range functionality or applications at the moment. It's all done in the GUI software.
Okay, thank you. Is it possible to provide the RT range configuration post-test, i.e. run all the tests with just motion packs?
Yeah, so the RT range hardware is, because it's just processing, there's no sensors in it. You don't need it during the live test. The reason it's really useful to have is because it provides all of those measurements in real time. So the test engineers can be checking the output of the range during the test to make sure that all of the equipment is working as it should be, and that the test is passing or failing. So if you run the test, you can see there and then whether it's failed, and you can repeat the test as many times as you like until sort of you get it right. But in theory, if you just have RTs, you could do all of the functionality of the RT range is contained in the post-processing suite, so you could do it all after the test. You just wouldn't get that real-time live feedback benefit from it.
Okay, thank you, Kit. Is it possible to post-process a small part of the measurement, not the whole test?
So if you have, I guess this is in the scenario where you haven't live recorded any files, you can actually, if you've got a sort of a long RD file, you can post-process it into an NCOM file in NavSolve, but obviously that will then generate a long NCOM file which contains all of the measurements. But you can open this NCOM file in NavGraph. So I'll just quickly do that. So for example, if I open this NCOM file here, so this currently is quite a short file anyway, but if we still wanted it shorter, we could drag these cursors to the start and end point of the test run, for example. So say that we only care about this center part of the test. We can right click and select the region between the cursors, and that will generate a sort of a new tab just containing that snippet of the NCOM. And then you can export it to a single XCOM file. So XCOM is a different data format, but it's not really a data format, it's more of a wrapper. So it just, if you had multiple NCOM files, it would contain all of those NCOM files. But for a single NCOM file, XCOM is the same as NCOM. So if you use this export to a single XCOM file and give it a file name, snippet, for example, what that'll do eventually is create an XCOM file which is containing just the snippet of that NCOM, which you can rename the extension to NCOM because it's exactly the same. And then you've got an NCOM file which is just containing the relevant test data that you're looking for. And then when you use the post-processing wizard, the RT range post-processing wizard, with just a small NCOM, obviously it will only create RCOM. It will only create range measurements for that small section of the data.
Okay, thank you, Kit. There's a question about the RT range RT-V3 range unit. Are the RCOM and NCOM files generated together, or is everything in the RCOM file?
Yeah, so the RT3000 V3 contains sort of both the RT and the RT range hardware on one unit. But the functionality can still be used separately, so it still outputs an NCOM and a separate RCOM stream. They're not combined into one single measurement stream. So you can log them separately if you wish, or if you want both, you'll need to select both.
Okay, thank you. Is it possible to post-process multiple files with the same settings, or do you need to go through the GUI for each single file?
Unfortunately, the RT range post-process doesn't have a batch process option. So you can't process the same settings of multiple files with one click. You'll have to go through all of the files. The one thing it does do, so if you have a specific set of measurements which you want to add to the CSV file, the post-process tool does remember which CSV settings you've selected. So you won't have to go through and reselect those every time. You can just proceed past that and it will always contain the same CSV measurements.
Okay, thank you, Kit. That's all the questions we've had in so far. Does anyone else have any questions?
If, to point people towards the, so if you don't have questions now, but do think of questions later on, a good place to start to find answers is the OxTS support website, which is where sort of members of the support team like me and Lily submit articles containing answers to questions or information about specific features, for example. So you might find your answer in an article there.
Okay, thank you, Kit. Just another question's come in. Is batch processing capability or an API in the roadmap for RT range?
Oh, I don't know the answer to that question now, but I can get an answer and send you an email with a response after the webinar. But I don't think so. But it might just be that no one has suggested it to them, so I'll ask them and suggest it as something that we can improve.
Okay, thank you, Kit. Does anyone else have any questions? If not, we'll just end the webinar now. And if you do have any further questions, yeah, as Kit mentioned, you can go to our support site, just listed on the screen now, or you can email support@oxts.com. Okay, well, thank you everyone for coming.
Thanks everyone.